Hey guys, good evening. I'm back. Sorry, my internet got disconnected.
Yes, Mani, please carry on.
Yeah.
Yeah. I think some people are yet to connect again, right?
Yeah. Can you just wait for a minute?
Yeah. I'm really sorry for the inconvenience. Yeah. So okay. So quick discussion. So if you have any queries, you can ask. So in the meantime, the people will also join. Hello.
Team, are you there? You have any questions so far?
So in the meantime, the people will join. So if you have anything, you can interact us with us.
I'm going to ask the question to other people if you're able to answer. Manoj, what is Spark?
Spark is a big data framework. It is one of the open source cluster designed for real-time data analysis. The Spark is written in Scala programming language. Why Scala means because it is intelligent and easy to use.
Okay. Majnu? Majnu, are you there? Jalishmi, are you there?
Yes, Mani.
Okay. How it is differ from the map reduced to Spark?
MapReduce is using the disk to, input-output operation is very high in MapReduce, and Spark is in-memory operations, cluster computing. So it is 100 times faster than the MapReduce and 10 times faster than the disk operations in the MapReduce.
Okay. Good. Okay. Who else is there? Srinivas. What is the batch processing? What is the parallel processing?
Batch processing, it's like historical data, and the parallel processing like the real-time data, what we got in cricket scorecard up to date.
Okay. Venkat. Venkat.
Yeah, man.
Okay. Venkat, is that only so why this Scala? Some people are telling Scala, and all when we are writing about Spark. Can't we write only in Spark itself the queries? Why we have to look at some Scala? Can't we write in the Java code or can't we write in the Hive or HBase? Why Scala is coming to picture? Can you just deep about that?
I think Scala is something statically and strongly. It's a very tight language. It also runs on JVM, but Scala is more powerful than. It's a strongly typed language.
It is more related to the functional programming.
Yeah, correct. It's a functional. Yeah, it helps. Like Java, it's like a functional language from start. It's a good.
So we can reduce the verbose compared to the Java. I mean, if you write Java 10 lines in Scala, we can write in 2 lines or 3 lines.
Yeah.
Good. Okay. Okay. I think we got that. So Ravi, we can proceed more. So any questions to Ravi? Are you getting what is Ravi is telling so far?
So I heard this Facebook friends request is using graphics. Is it right?
Facebook friends request is using?
Yeah, friendship, that graph is, that algorithm has been generated using the graphics or Spark graphics. Is it right or not?
I think that is graph database. That is different than graphics.
Okay.
I have
This case using graph APIs, but not exactly GraphX. It is GraphX. Hello?
I didn't get you.
That is graph API. APIs they are using,
okay,
but not exactly GraphX.
Okay. So where exactly the graphics is in actually use case it's coming?
So graphics has many use cases in the case of if you combine with the data science and if you want to work with the data science, at that time we have graphics uses.
Okay.
Okay. Over to you, Ravi.
I think, yeah, so I think almost all people joined, I think so. So shall I start the session?
Yes.
Yeah, so I will resume it. Okay, so sorry for the inconvenience once again. So, okay, so we have seen about the modes of processing. The modes of processing is batch processing, interactive processing, and streaming processing. It is a question asked by myself to the trainer. So at the time of Hadoop, so if you want to do any real-time processing, like if you want to, we are having webcams, so how to do it, or if we are having cameras, so how to do the real-time processing in the by using the set. At the time itself, they said the answer is Spark. Okay, Spark is the only one which can run the real-time processing. Okay. Majorly, we can say that okay, real times like we can take cricket info like that we can do it. Sorry. Yeah. So various workflows, libraries as I told. So we are having like a machine learning, text processing, graph processing, batch processing, structured data processing. So I think Matej Zaharia, so he wants to put everything into one particular unified stack. So that is the main reason why Spark is popular also. In the case of Hadoop, so we can say that we have Hive, Pig, everything we are having. But if we want to install, we have to install each and everything with the different versions. Okay. So here the difference is once if we install Spark, we have Spark R, PySpark, everything will come into the picture. For example, Spark plus R. Okay, it is nothing but Spark R. It is an inbuilt option in the Spark itself. If anyone wants to do Python with the Spark, somebody will be specialized in Python and they want to integrate with the process with the Spark. At the time they can use PySpark. Like that we can use with the variety of language that is users can use attached with the Spark also. Once if you upgrade the version say 1.6 or 2.1, so all the ecosystems, all the libraries will be also updated. So that is one of the advantages of using the Spark. Okay. So what are the conventional data processing? So we are saying Spark and what are the conventional data processing? So here we can say that so the conventional data processing for, as I told, you can use it for batch processing and various APIs and tools also required for data processing. If we take Hadoop, so what are the tools associated with the Hadoop? Hello. So what are the tools associated with the Hadoop? Okay, they are all like, so Pig, Hive, everything we have to separately install, then we have to use along with the Hadoop. Okay, then the version compatibility, as I told, if we have a higher version of Hadoop 2.7, then the lower version of Pig or Hive, it has to upgrade it to the version compatibility of the latest version of Hadoop. So here, if we once upgrade with the 1.6 version to 2.1 version of Hadoop Spark, so everything will be upgraded along with the Spark. So that is one of the advantages of going for the things. Otherwise, the admin has to each and every time he has to install the things manually and he has to configure the according to the latest version of the project what they are going to use. That is the advantage of going for Spark. So he smartly think, the Matej Zaharia smartly think about the concepts and he put everything into a single concept of Spark. Okay. So I have a question. So some people are saying Spark is 10 times faster than Hadoop. Some people are saying 100 times faster than Hadoop. Can anyone say what is the reason behind it? What is 10 times and what is 100 times? Actually, I'm asking a question. So what is the difference?
The difference is your cluster. I mean, if you have the same set of clusters for running your Hadoop jobs, I think using the same number of clusters, you can achieve 100 times faster throughput. And let's say 10 times faster as you can also reduce the number of clusters and still Spark will be performing 10 times faster than.
Yeah, that's fine. But the reason behind is, so 10 times faster than Hadoop is, for example, if you have 8 GB of RAM, okay, and if you have the process of data is 10 GB of data, okay. So what Spark will do is it will take the 8 GB of data first for processing, then it will keep the remaining 2 GB of process in the hard disk. That is a commodity hardware what we use in the Hadoop also. Okay. So what will happen? The 10 GB of water data is split into 8 GB and 2 GB, and the first priority is first 8 GB of data will be processed in the by using the RAM. But the 2 GB of remaining data will be saved in the hard disk. It is coming with the Hadoop speed because Hadoop also uses the hard disk commodity hardware for using the data
Sorry, we
processing.
are getting some echo.
Whatever do, sorry?
We are getting some echo.
Yeah, I think so. Everyone muted the speakers, right?
I have muted everyone now. Okay, Ravi,
Yeah.
I have muted everyone and then I have unmuted you.
Yeah, sure. Thank you. So the remaining 2 GB data is saved in the hard disk itself, right? That remaining 2 GB data is saved in the hard disk, and the 8 GB data is processing by using the RAM. Okay. So initially what we said, Spark is processed by in-memory processing. That is real-time processing is processed by the RAM. But if we save the remaining data in the hard disk, the fetching time from the hard disk to the RAM, it will take some time. So that's why they are saying that it is 10 times faster than Hadoop. In the case of 100 times faster, if you have everything running on that is all the inputs and outputs are running on RAM, then there is no need for a hard disk from fetching the input and running in the RAM. So it is 100 times faster in the Spark. So I have a slide. So in the slide you will see the deeply how it is.
Ravi, one question. Ravi,
Yeah,
one
yeah.
question. It is
Yeah.
100 times faster than MapReduce or Hadoop?
MapReduce.
Because
Exactly. Here I have defined MapReduce. Okay. The Hadoop in the sense, so
okay.
HDFS is always there. Okay, so we can use the beautiful thing about the Spark we can say is they kept storage as we can use HDFS, we can use S3 or any storage we can use. Okay, from that we can fetch the data and we can process the data. That is the beauty of Spark. So like Hadoop, they did not do like a. There are two major components like one is Hadoop, one is HDFS, and another is MapReduce. They are concentrating only on the engine, that is the Spark engine. Then the remaining things like data saving, that is so storage, everything they kept as anything whatever you want we can use, whichever is compatible like S3, HDFS, anything whatever we want we can use it. Okay, so this the 10 to 100 times faster I will clearly say in one more slide. Okay, yeah. Then sorry. Okay. So easy to use. So in the case, it is very much flexible. As I told, we can easily integrate with the storage database. Okay. So that is a very much advantages of going for the Spark. Yeah. So this is the basic introduction of the Spark. So in this we have covered how it is working, what is the basic history about the Spark, and who introduced the Spark, how it came into the Apache Open Source Foundation, and what is the advantage of Spark with the conventional technologies. So these are the brief introduction. So we have so far covered in this topic. So if you have any queries, please ask me. Hello. Yeah. Shall I move on to the next slide?
Yes.
Yeah. So as we define that it is 10 times faster and 100 times faster. Okay. The basic reason is yes. See, here is the reason. So we are running a MapReduce process, right? So in the case of MapReduce process, we are having basically mapping and reducing process. So we are fetching the data from the HDFS, then we are going to give the input as a for the map. Then again after processing of the map, we are going to save in the temp file, right? So the temp file is again one more we are going to hit the IOs. Okay. Then again for the reducer, it is taking the input from the temp file, then it is processing in the case of reducers, right? So if you want to do this kind of processes, you can count the number of IO hits. Okay, the IO hits is nothing but number of times input is fetched and number of times the output is saved in the disk. Okay, if we count for running a 6-step process, we are having nearly 12 IO hits in the process. So it is again going to reduce the speed of the thing. As I told, if you are for fetching, we are taking some time, and for writing one more time it is going to take. Then again for fetching one more time it is taking. For writing again it is going to take some more time. Can you speak? Yeah, we'll cover one by one. Yeah. So here, if you take in the case of Spark, so we can see the number of IO hits. For performing a similar operation when compared to the MapReduce, we are having only 2 IO hits through the entire process. So first thing is fetching the process, and the last thing is saving the process. Okay, in between everything is going to run in the RAM itself, because there is no need for storage the output in the temp file or the hard disk when it is not necessary also during the process. So this is the reason why we are going for higher speed when compared with the MapReduce. That is the exact reason why we are going for it. Okay. So what are the benefits of Spark on the Hadoop? So this is the main reason. The benefits of Spark is, okay, so we can say that the abstraction is very easier, and also we can go for the multi-level processor. So whatever you have seen in the Hadoop, almost everything we can see in the Spark also. But the everything which is running on Spark is live streaming of data, that is the processing of data. Not only processing of data, we can do the batch processing, that is a historical data also. Okay, we can, if you can ask, we can use a yarn, or if you want to process mesos like clusters, everything also we can do in the case of Spark also. We can use yarn cluster for running the Spark also. So we will see one by one in the forthcoming slides. Yeah. So unified stack. So what is unified stack basically? So unified stack is whichever it is closely associated tools. Okay, the closely associated tools are integrated. We can say that it is a unified stack. We know very well in the case of Hadoop, everything is running on top of HDFS. So in the top of HDFS, we have Yarn, MapReduce, Hive, Mahot, Impala, Test, like that. A number of tools are associated with this. Okay. So can anyone say that what is the difference between Hive and Impala? Okay. Yeah. So can you? Yeah.
Yeah, the Hive SQL queries are converted into MapReduce, but whereas the Impala does not use MapReduce, it directly executes the queries on HDFS.
Yeah, that's fine. It directly executes, but any technical word, can anyone add it? So basically, Impala is in which distribution?
Cloudera.
Yeah. So yeah, basic technical word I am just expecting. The answer is very fine, but yeah.
It's an in-memory computation.
Yes, exactly. So that is the in-memory
architecture.
Yeah, sure.
Can I ask a question?
Yeah, please. Yeah.
Okay. Do you think, when going with Spark, all these memory issues, they won't come into existence? Because I work for a client, it's a global banking client, and they were on Hadoop and they plan to move on to Spark. Okay. And once Spark, then all these issues, like running out of memory, because obviously everything will run in RAM or the computations, and that amount of memory and all. So they didn't invest much time into learning how to solve that issue, and what they did, they jumped to an ETL tool.
So even so you might have heard some tools like Thursday and all, they are by replacing MapReduce, we can achieve the same Spark with the Hadoop engine also, Hadoop also. Okay. So that we have a single slide regarding this. I will show you that one.
Sure, sure.
Okay. So as we have seen, the best thing for storage is HDFS, right? So HDFS is we can say we cannot beat the HDFS because it is accepting any kind of data, and it is the best for storage of the storage of data. Okay, it's a variety of data like unstructured, semi-structured, everything we can store in the HDFS. Okay. Then in the case of browsing, we can use yarn as well as we can use for mesos cluster also. Okay. Then in the case of core, so everything is running on top of the Spark core. Okay. The Spark core, we have seen about the SQL, Spark SQL libraries, Spark streaming we have seen, machine learning we have seen. So graphics, everything is running on top of Spark core. Okay. As I told, so the main important thing whenever we go for a new technology or new framework is, first thing is whenever we compare the Hadoop with the conventional techniques, you will say we can use less number of codings when compared to the conventional techniques. So here also the same. We can go for less number of codes in the case of Spark, and it is faster than conventional technologies. Second one also we will say in the case of Hadoop, it is if we compare with the conventional technologies, Hadoop is faster than so RDBMS we can do very much faster in the case of Hadoop. So the first thing what they are thinking is less time, less number of codes and higher speed when compared with the conventional technologies. That is the main success for a particular framework. So that we are saying that that's the thing I told, right? Thursday, but using Thursday also we can achieve the higher amount of speed. Okay. Yeah. So why I want to switch into the Spark? The first thing is easy to use. I will say how it is easy to use means language also it is easy to use, as well as the integration with the components, integration with the libraries also it is very much easy to use. And as I told, it is fast. We have seen about the 10 times to 100 times fast. General purpose, it is scalable. Okay, the main all the distributed systems nowadays, what they are looking is scalable and parallelly processing the data, and optimize fault tolerant. Okay, can anyone heard about the fault tolerant? What is the fault tolerant mechanism using in the Spark? Okay, can anyone quickly brief? RDD is a different concept, but so RDD we can say, but the exact yes, exactly.
Lineage
So by
graph.
lineage graph, we can do the lineage. By using the lineage graph, we can go for the fault tolerant mechanism. Okay, I will explain about the lineage graph, how it is working, and how they are using the lineage graph. Yeah. So as we have seen, we are having batch processing, stream processing, iterative, interactive. Okay, so iterative, interactive, and all. Initially, I think I have explained about the iterative and interactive. And the streaming processing we can use for Storm, batch processing we can use for Hadoop. So these are different types of things what we are using. Okay, that's why if you go for any job descriptions, they will ask with so Spark. Okay, they will ask Spark, then Spark with Kafka, Scala, Storm. So these are everything available in the particular job description if you go for any Spark kind of jobs. Okay. Okay. So now we are going for the a quick view of the architecture. So it is almost similar to the Hadoop's Yarn architecture. In the case of architecture of Yarn, so we have a resource manager, we have node manager, we have application manager, so we have nodes. So similarly, here we are having architecture like driver program, cluster manager, worker node, executor, and the task. The name is different, but the concept is almost similar to the Yarn. Okay. So the driver programmer, we will go through a very quick view of the architecture. What is a driver program? So driver program is the one where the program is saved into the driver node. That is called driver program. So here, similar to the so resource manager, we have a cluster manager. The cluster manager it is going to manage all the clusters at the time. So we can say these kind of things are comes under the master node, and remaining and comes under the slave node. Okay, so here we are having worker node. In the case of yarn, we have the node called, so that is called node manager. We have, okay, node under the node manager we have tasks, that is we can say that containers, everything will come to the picture. So similarly we have worker node, executor, and the task. The work of the worker node is to get the job, and it has to execute through the executor, and the task will be executed with the tasks. So this is the task that is available. Similar to the yarn architecture, we are also having the architecture, and instead of container we are having executor. So this is a brief overview of the architecture. Okay. Actually, yeah, I will answer the queries because I am not able to see very clearly. Okay. So once if I complete the task, I will come into the questions. So driver programmer, as I said it, so driver programmer is a program that defines the what is the transformation actions in the RDD. Okay. Similar to our nodes, like how a name node is executing, how the second node, we are everything here saying at the transformation and action on the RDD. Okay, we will see about the RDD the next slides. So RDD, in a brief, it is nothing but a resilient distributed data set. Okay, just it is a data set for doing the process. Okay, it will take the Java object and it will process into the jobs. That is, by using the RDD, we can submit the jobs. Okay. So in the driver program, it is the node is called a driver node. It is on the in the driver program we will have the program. Whatever we are going to execute, it will be in the driver program. Okay. So cluster manager. So obviously, if you go for any distributed system, we need some manager to manage all the activities. So that is called cluster manager. In the case of this one, it is the main reason why we are going for cluster manager is it has to allocate the resources. For example, for a particular task, we need 1 GB of RAM. We need 1 GB of so hard disk. We need 1 GB of a core. For example, if we are saying like this, it has to allocate the particular resource to the Thanks. Yeah. So it has to allocate the RAM, CPUs, everything in the node. Yeah. The worker nodes and the name node, the node manager. So in the case of how do we yarn, we will say that it is a node manager. In the terms of Spark, we are using the term called worker nodes. Okay. So the same, almost the same work, the node manager, what it will do in the yarn architecture, here it is doing in the case of worker nodes. It is manages the executors. We have seen executors. The executors name in the case of yarn is a container. So it has to do all the execution work inside the container. If it takes more than the resource which is allocated, like example, if you are allocating 1 GB of RAM, and if it is allocating more than 1 GB of RAM, the work of the node manager is to kill the executor. Okay. So if it is not behaving, then the worker node the node manager has to kill the executor. Yeah. That is again the task is the smallest unit of the work. As we said, in the case of data node, at last all the process, everything comes to the data node and the process, and it is going to save in the HDFS. Similarly, we are having the task. Task is something with the smallest unit of the work in the Spark. Okay, it sends the executor after the completion of the work. So that is the work of the Sun. And after the execution of the process, as I told, we can save in, we can save in the S3 or HDFS, and wherever we comfortable to save the data, we can save in the particular storage. Okay. So far any questions about it? Hello. Yeah. So far any questions regarding this one? Because architecture is yeah. Hello.
Yeah, can you quickly show the architecture diagram, how this, how the orchestration goes with Spark?
Architecture diagram. Yeah.
Yeah, I think the first one you showed earlier.
Okay. You want to go back, right?
Yeah. Okay. Yeah. Okay.
Are you able to see it?
Yeah, I mean, okay.
Yeah.
So everything goes
almost,
through the driver. Mhm.
Yeah, it is a, if we already gone through the yarn, it is almost similar to the yarn that you
Okay.
can see. The name is somewhat different. So there we'll call the resource manager, node manager, container. Yeah. Here the name is cluster manager, worker node, executor, and the task. So the next slide I have compared.
Okay, thanks.
Yeah. Here I compare with the worker node with the node manager, then task with the data node. So we can compare if we this analogous to the yarn. Yeah. So the main definition, what we can say for Spark core is, if anyone asks what is a Spark core, then we can say the Spark core is for scheduling, monitoring of the distributed engine. There is a small definition we can say for the Spark core. Okay. Then the extensive processing, as we told, we can go for APIs and we can go for a shell, SQL. That's what we are going to into the next things practically. Yeah, this also we have seen this storage there. Yeah, this is also analogous. So whatever we have seen, right, it is analogous to your HDFS. Okay, so we have name node, master daemon, the data nodes in the slave daemon. I think you might have come across it. Right? This is for the in the case of yarn. The yarn we have resource manager. So master we have node manager, application master, and we have the data nodes. Inside that we have the data nodes. Okay, so running on to the modes. So what are the modes of operation? So in the case of Hadoop also we have seen about the various modes of operation. Here we have local mode, cluster mode. In the cluster mode we have standalone mode, mesos and yarn. Okay. The local mode is nothing but what we are using in our, so a local PC, we can run everything into a single system. That is a single node, everything we can run it and we can process by using the Spark by installing in our local PC. In the case of clusters, okay, in the case of clusters, we have standalone cluster, mesos cluster and yarn. Okay, standalone cluster. Okay, in the case of mesos cluster, if you take very big companies like Amazon, they are actually going for the mesos cluster. Not all the companies are going for the mesos cluster because it is somewhat a kind of a high-end level. In the case of yarn, if you go for any clusters, yarn is very much compatible when compared with the other clusters. And if you want to go for, yeah, and if you want to go for any small level clusters, if you want to do any 4 or 6 nodes of cluster, then we can go for the standalone clusters. Okay. Yeah, in the case of local mode, we are using IDEs. Like in the case of Spark, the very much familiar tool is IntelliJ. So I think most people heard about the IntelliJ. It is almost similar to Eclipse, and we can easily practice by using the IntelliJ because it is having inbuilt options of Spark built-in libraries, SBDs. It is having Spark SBDs. We can run Scala, we can run Java, everything on in the IntelliJ IDE. It is also easy to debug option also. Easy to debug, easy to test, easy to run a task in IDEs also. So one more mode, what we can do is we can go for REPL. So REPL we can go for command based operation. So yeah. So we have command based operations. So like that we can install and we can go for any command based operation. The shell is Scala shell. We can use the Scala shell for going for the command based operations. Okay. So we'll see one each and every example for each and every process. Okay. Yeah. So in the case of testing, we will go for the standalone mode. Yeah. See, in the case of a quick and a small cluster, we say example 4 to 6 node, we can go for the standalone cluster. So standalone cluster is mainly for if you want to run a process, if you want to debug, like the testing kind of things, it is very much compatible with the 4 to 6 node of clusters. Okay, it removes the overhead of master and slave process, and if we have any problem in the real time, so before going, we can go for the standalone cluster. Yeah. So in the case of yarn, it is very much familiar. Okay, we know what is the master node or what is the slave node, or what are the tasks of master node, what are the tasks of the slave node. Everything we know very well. So as we previously mentioned, we have a resource manager, node manager, and the executors. We have the data nodes, everything available in the Spark. That is the architecture based on the master slave architecture. Here we have n number of nodes, and it is scalable as per the requirement needs. Okay, so now we are coming into the abstraction. So what is basically abstraction? It is a fundamental element of the process of the data. If we say any ecosystem, then we can easily find out what is the abstraction of each and every ecosystem. For example, if we say anything like a hive is, the table is the abstraction of the hive. In the case of relation, we can say the relation x is equal to load the particular path with the particular schema. So it is relating one x with the loading the particular data. So if we say T, that is mainly concentrating on the relation. And in the case of SQL, we can say that it is a schema. Schema is very, very important, and we can imagine the first thing as a schema in the case of SQL. Similarly, in the case of Spark, if anyone says Spark, so someone also recollected, if they say Spark, you said the immediate answer is RDD. Okay, 1.x is the first version, that is 1.1 version, 1.2 version, 1.6 version, that is RDD is used. In the case of 2.x, that is the second version, they went for data set. Okay, this is also one of the major interview question also. What is the difference between 1.x version and the 2.x version? The first version they are using RDD, the second version they are using the data set. So we are going to see about the detail of RDD and data set. So what is RDD and what is data set, we are going to see in the detailed manner also. Yeah. So what is RDD? So someone said the explanation that it is a resilient distributed data set. So what is resilient? Resilient means it cannot vary the value. That is a resilient distributed data set. It is a data set and it is a collection of data partitions called RDD. Okay. So the main advantage why we are doing for RDD is it is immutable. Immutable means once if we fix the value, we cannot change it. That is called immutable. For example, I am planning to go for a journey from Bangalore to Chennai. That means my path is fixed and at any cost I am not going to vary the path. So that like that we can say that if I fix a value x is equal to 10, for example I is equal to x, I is equal to 10, we cannot change the value at any part of time. It is fixed. Okay, that is what we are saying is a immutable. Then fault tolerant. As I told, we are having a lineage graph. Lineage graph similar to our similar to our UI, that is user interface in the case of Hadoop. We can also see the path. What are the path it is? What are the stages it is crossing, and what are the stages it is associated with this? Okay, it is fault tolerant. For example, creation between one RDD to another RDD. What is the link? If there is any problem, then they will go to the previous RDD, then they will see what is the problem with the previous RDD. So that is a fault tolerant mechanism, and that is distributed. Nowadays, whatever we are using, most of the things like Kafka, everything is distributed, and we are doing the distributed processing. Okay, so here RDD is the major advantage is here we are having either structured data and unstructured data involves into the RDD, and the Spark allows the RDD to process the structured as well as the unstructured data. So this is the basic thing about the RDD. So RDD is nothing but a resilient distributed data set, and it is associated with the collection of data partitions. Okay. Once if you see the example, then we can easily understand about what is RDD. Okay. So the same thing. So we have one master. Between the master and the slave, we have distributions. Okay, that is parallel distribution. In the case of processing, it is in-memory processing. That is because of high speed we are having the in-memory processing. The slaves, what are the slaves we have seen? We have seen executors, okay, everything, task, everything we have seen in the slaves, okay. Okay. So for example, what are the ways to create RDDs? There are two important ways, that is the two major ways to create the RDDs. One is parallelizing the method. So another one is method called text file method. Okay, either you can, by giving the value, we can do RDD, we can create RDD, or by giving the path of the file, text file, we can create the RDD. Okay, so a small example I will show. So this is actually a Spark shell. I am using 2.1 version. Here I am typing val. Val is nothing but value. Value is immutable. Val is equal to 1 to 10. Okay. Now I am giving enter. Okay, sorry. Val x is equal to 1 to 10. Okay. So now it is saying I am getting the range of values from 1 to 10. So here if you notice, say I have not given any semicolon. By default, Scala is understanding that there is no need for semicolon. If it is the case of Java or C, it will show from exception like, so we have to put the semicolon, right? So in the case of Scala, it is intelligent in by using these kind of values. For example, if I am giving a print value, there is no need to give for a semicolon. Even if you are giving also, it will not throw any exception. Okay. So what it is saying is, it is saying an immutable range of values from 1 to 10. At any point of time, I cannot change the values. Okay. So this is called immutable. Var is immutable, and we can use var. Var is mutable. Okay. I will tell the concept about what is immutable and mutable. Okay. So we can say that. So for the val and var, we'll see the difference between val and var in the next session. Okay, this is the basic example. What I have shown is the basic example of val and var. Okay, yeah. So we can go for arrays. We can define. If we are not defining anything, it will take us a range of value. If we define, then it will take us a array of values. Okay. The next task is we have to parallelize it. SE is nothing but Spark context. Okay. We go for the deep studying of Spark and context values. We will come across the values called Spark. What is Spark context and what is the parallelize in the next sessions. Okay. So here we are doing the parallelizing operation. Okay. The parallelizing operation and the creation evaluation, everything comes under one part category called transformation. Okay. So there are two major operations. One is transformation, another one is action. Okay. Transformation is the one which creates new transform data sets to the existing RDD. Okay. For example, I am having an RDD. The RDD is val x is equal to 1 to 10. Right. If I want to create one more RDD, then I have to use val y is equal to SC, that is Spark context dot parallelize of x. Okay. Here it will not give the output. So it is giving one more RDD. So have you noticed this? Val y is not the output actually. Val y is nothing but one more RDD which is created from the existing RDD. This is called a transformation. See? Here we are having the definition is RDD create from the existing RDD. Okay. If I want to explain in a very short form, so if anyone come across the concept of lazy evaluation in the pig, okay, can anyone say what is lazy evaluation in pig? Hello? Hello? Yeah. Can anyone say what is the lazy evaluation in pig? So we are loading a value. As I told, pig is, the abstraction of pig is relation. For example, we can load x is equal to load of the particular path name followed by the schema. Even if you are not giving schema also, it will accept. Okay, then we are giving y is equal to filter by or group by or order by. Okay, we are giving one by one step. Okay, yeah, can anyone explain what is a lazy evaluation? Hello?
Lazy evaluation is nothing but whenever it is required, it will call that particular RDD to get into the
Yes.
actions.
Yes, exactly. So whenever required the output, at that time we can get the entire value. Okay, that is entire result we can get through the transformation. Sorry, I'm able to see only the few seconds the questions and the. Okay, well, first I will complete this particular task, then I will come to the question section. Yeah? Okay, so what is action then? Action is the one, whenever we go for a dump or store command in the pig, it will return a value to the developer. That is, it will start executing the particular process. Once if we give the value of dump y, then it will start executing x is equal to load function, y is equal to filter by operation, and z is equal to filter by or group by operation. Everything it will start executing. So that is particular thing is called action. Okay. See, similarly, here if we see, first we are seeing val x is equal to 1 to 10 is an RDD. Here we are creating one RDD, that is val y is equal to SC parallelize. It is also not giving the operation. Once if I do y dot collect of, so it will do what are the operations is, then if you go for collect of y, sorry, just one mistake. So once if we give like the run command what we are using here, then it will start executing all the process. Yeah. So, okay, there are a particular set of operations for transformation as well as the actions. Okay, as I told, so mapping, flat map, filter, group by key, reduce by key, these functions are related to the transformations. So it will, that what is transformation? It is creating a new RDD from the existing another one RDD. This is transformation. It will not give the direct output. Okay, for example, mapping and reducing are two different processes. Once the mapping is completed, it will not give the output. Okay, it will save the value of the temporary data. Then once the reducing is complete, then only you will get the output as a text file or CSV file or sequence file or whatever you want in the execution method. Similarly, transformation is one part. It is converting one RDD into another RDD. When you will get the output is whenever you go for collect of, count of, reduce of function, at the time only you will get the action or output or the result of the RDD. So these are set of transformation and actions, and each and every particular function has a particular work. So if you want to only flat map it or flat map it, or if you want to function filter a function, everything is depends upon the transformation as well as the actions. Here we are seeing that the filtering command. So some of the transformations we are seeing here. So filter of, distinct of, union. So all the functions we can do in the transformation actions. Yeah. Similarly, here we are having reduce command, collect command, count command, everything in the actions. That is action functions. So here it is how it is working on. So we, as I told, we have transformation and action. Similarly, how it is having map reduce function, mapping and reducing function. Here we are having transformation and action functions. What it is happening? First we are creating a new RDD. The new RDD is created by giving the function val is equal to particular data or particular storage location. if we give the particular storage location file, then that is called text input file method. Otherwise, we are having the another one method is called, what is the another method? So we have seen two methods, right? One is creating new RDD by two methods, right? So we have transformation and the action. In the transformation, it is going to transform one RDD into another RDD form. Okay, once the action comes into process, then it is like doing with the reducer. It is converting all the RDDs into action and it is storing the data in the HDFS. It is very much similar to the MapReduce concept. Okay, so everyone understand this concept? Hello?
Yes, yes.
Yeah.
Yes, Ravi.
Yeah. So again, we are having a DAG function, that is a direct acyclic function. Okay. So these are all we can see the separate topic because it will take some more time for me to take into the concepts. Okay. Yeah. The main advantage is, so here only the fault tolerance is coming into picture. Whenever, so we are having a very sequence of we are having a very sequence of process going on. So we are creating one RDD, we are transforming one RDD into another RDD, then we are doing the transformation into action from one RDD into the actual output. We are going in a very sequence manner. If there is any problem in the process, by using the lineage graph, we can retrieve it. Okay, so that is the fault tolerant mechanism, how it is working in the case of RDDs. Okay. And as I said, we have a lazy evaluation like in the case of pig. So once if we give the action command, then only all the RDDs will convert into the action. Okay. So this is the basic and the very fundamental things about the RDD. Okay. Yeah. So it is very much similar. As I told, right? We have a dump command in pig. Once we give the dump command, all the process of filter by command, loading command, everything will start working. And if there is any exception also, we will come into the notice. So what is the exception we are getting in the case of dump command? Okay. So it is using a following lazy evaluation. And here we have two major operations called, one is transformation, another one is the action. Okay. So I think we have crossed the time, 11 o'clock. If you have any doubts, please ask me. Actually, I have missed many queries, whatever you have noticed. Yeah.
Yes, any questions you have?
Yeah, please.
Ravi, Raju,
Yeah. Yeah, please.
how we apply the Hive context inside the Scala?
Sorry, can you explain?
Raju, can you repeat?
You want to integrate the Hive with this Spark, right?
Hive context inside the Spark.
Yes. So in the case of Hive, Pig, other ecosystems, whatever we are having already a cluster, right? Yarn cluster. So we are running different modes of clusters, right? So one is standalone, and we are using local mode, and we are using yarn mode. So majorly with the yarn, we can associate all the ecosystems, whatever we are using with the Hadoop, right? So you can integrate Pig, you can integrate the Hive, everything we can integrate into the Spark also. So that is possible.
So
have I answered the other question? Yeah.
I understand. So that means the Spark library contains Hive related things, Pig, everything will be there, right?
Not exactly. So what I am saying is we can integrate Spark while using with the yarn cluster. We can integrate all the ecosystem, Hadoop ecosystem, whatever we are using with the Spark Hadoop with the Hadoop ecosystems. I am saying.
Thanks.
Yeah. Yeah, actually, I have a few more slides also, but due to the time limitation, I am limiting the slides.
We'll discuss more hands-on session kind of way tomorrow. So today just I asked Ravi to explain what are the context, because we have to recap all the concept, right? So ask Ravi to
Yeah.
take over all the concept today. So tomorrow we'll more do the exercise oriented. Okay. So ensure that you have installed the Spark on your system on the either an Xbox or the virtual box all the way, and also we have a Cloud Lab, right? So those kind of mode you can start working on that from tomorrow. So today we are just refreshing.
We can use Windows also, Mani.
Yeah, we can use in
Yeah, we can use Windows. I'm using Windows only.
In Windows also we can. Yeah,
Yeah,
yeah.
we can use Windows only. See, I'm also having IntelliJ. If anyone wants to work with IntelliJ, we can use the IntelliJ also. So I have we have to, but the thing is we have to put all the inbuilt files associated with the IntelliJ to process the task.
Scala ID also available here.
Yes, Scala ID also we can use. So the only problem with the open source is, so all the things what we are using, we have to work out some other things. We have to, there are many repositories available like GitHub. We have to fetch the files, whatever we are using, and we have to put the SPT files into the IntelliJ or REPL, everything we have to give as an input, then only we can process it. So that is we can say that a small drawback about the open source.
Ravi, Pratik this side.
Yeah, please go ahead.
Was in Spark 1.x, was Hive context available at that point of time, or was it available only once 2.x version came into existence?
Yeah, the difference is between 1.x and sorry, the difference between 1.x and 2.x is the major difference is the RDD and the dataset concepts only. Okay, so in all the versions we can mostly have used in 2.1 context, that is Hive only they are using, but in the 1.x almost we can do it only. I will just verify it and I will tell you tomorrow. Because in the 1.6 session I have not tried with the Hive, so mostly it will be compatible only. I will verify the thing.
Okay, because I never worked on RDDs. I directly start with data.
Yeah,
So
sure.
that was my question. Was it available at that point of time also, or was it, it came into existence only?
Yeah. So the one more advantage of Spark is we can easily like integrating with HDFS, like integrate S3 everything. We can integrate it with the visualization tools also. I think in the many of the companies you have started working with the that is integrating with the Tableau or ClickView, like integrating with the visualization tools. That facility is also available in the Spark. We can easily integrate with the Tableau or any visualization tools, and once the process is over, we can visualize by using the BI tools. That advantage is also having in the case of Spark. So whenever if you go for any client, they will ask only the visualization data. They cannot understand whatever you are saying already, everything. So the client, they want only visualization. What is the profit or what is the increase in manufacturing, like that they will ask only in the graphical manner. That is possible in the case of Spark. That is an advantages in the case of Spark. Yeah.
Okay, good Ravi, for the very clear intro of what is the Spark and what are the various components are available in the Spark, and then how to start the Spark, and then how the RDD concept can be used for our programming. Scala part you have been explained and covered. Thank you very much for the conceptual level of coverage of end-to-end of the first level of the Spark. There are a lot more to go on this particular field of Spark and then Scala. We'll continue over there for tomorrow also. We'll try to learn more on this particular field of Spark, and then we'll do the so many hands-on sessions, and then we'll try to do some small POC kind of programs, sample programs. We'll work it out to make sure that everyone is the comfortable, everyone is understand, and then they are very much able to motivate themselves to do any kind of project work in their organization. Okay, so that's the kind of level of stuff we are looking forward from the all other people also, to ensure that you are learning and then you are trying to implement on a day-to-day life of the programs. Okay, thanks all, thanks for everyone. So is there anybody want to have a word of thanks for today's session? Who want to start?
think everyone is looking for the time. I think I have taken more time. Really sorry. So I have to first say that for this very nice opportunity
They're not
to my
sleeping. They are always try to learn. This is a very passionate team. They are not sleep. Okay, every session is over. We'll just have a bit of thanks sessions for 2 minutes or 1 minute. We'll hear from the people. Okay. Yeah, go ahead, side. Your side. You can just share your vote of thanks or what is the way you want to share the feedback. Okay, go ahead. Manoj is talking but not hearing. Majin is talking, not able to hear. Rajivan is talking, not able to hear. Yes, sir, sleeping or what?
Hi Ravi, can you hear me?
Yes.
Yeah, I can hear you.
Yeah, this is a wonderful recap. The last week I have taken one session on Spark, but I think I missed so many things, but you covered a lot of things which I think you filled the gap whatever I missed it. Thanks a lot Ravi for doing this.
Oh, thank you. Thanks, Rajesh.
Thank you, Jayalashmi, for wonderful feedback. Okay, many people they type over in the chat window.
Okay. I think they are working.
Yeah.
Like they have to insert the headset and they have to speak. But it's fine.
Okay. Thanks all. Thanks for joining. We'll meet up on tomorrow. Same time, same place.
Okay. So tomorrow we'll see a hands-on section with the particular like a concept of CSP or something. We can do it. Okay.
Yes. Tomorrow.
Thanks for your time.
Totally hands-on.
Sure.
Yeah.
Yeah, sure.
Thanks.
Thank you all.
Thank you, everyone.